Now that we've prepared our data set, let's use CART to build a predictive model. First, we need to load the necessary libraries, rpart and rpart.plot. Now let's build our model. We'll call it tweetCart and use the rpart function to predict negative using all of the other variables in our data set, and we'll use the data set train sparse. We'll add one extra argument, which is method equals class, since we have a classification problem. We'll use the default parameters. When the model's done, let's plot it using the PRP function. Our tree says if the word freak is in our tweet, then predict true or predict negative sentiment. If the word freak is not in the tweet, but the word hate is, again predict true or negative sentiment. If the words freak and hate are not in the tweet, but the word WTF is, then predict true or negative sentiment. If none of these three words are in the tweet, then predict false or non-negative sentiment. This tree makes sense intuitively since these three words are generally seen as more negative words. Now let's go back to our R console and let's numerically evaluate the performance of the model by making predictions on our test set. We'll call our predictions predictCart and use the predict function to predict using the model tweetCart and the data set test sparse. We'll add the argument type equals class so that we get class predictions. Now let's make our confusion matrix using the table function. First we give the actual outcome, test sparse, negative, and then our predictions, predict cart. To compute the accuracy of our cart model, we add up 294 and 18, which are the number of cases we got correct, and divide by the total number of observations in this table. We can see that the accuracy of our CART model is about 88%. So how good is a simple baseline model that always predicts non-negative? To compute this, let's make a table of just the outcome variable, test sparse, negative. We can see here that in our test set we have 300 observations that have non-negative sentiment and 55 observations that have negative sentiment. So the accuracy of a baseline model that always predicts non-negative would be 300 divided by 300 plus 55, or about 84.5%. So our CART model is definitely improving over the baseline. So how about a random forest model? How well would that do? Let's first load the library, random forest, and then let's set our seed to 1, 2, 3 so that we all get the same model. Now let's call our model tweetrf and use the random forest function to predict negative, again using all of our other variables, and the data set train sparse. We'll again use the default parameters. The random forest model takes significantly longer to build than the CART model. We've seen this before when building CART and random forest models, but in this case the difference is particularly drastic. This is because we have so many independent variables. Here we have about 300 words that we're using as independent variables. This is rare in datasets that we've seen to have this many variables. So typically, in text analytics problems where you have so many different independent variables, the random forest model will take significantly longer than the CART model. So now that our model is done, let's make predictions on our test set. We'll call them predictRf and use the predict function to predict using the model tweetrf and the new dataset test sparse. Now let's make our confusion matrix using the table function. First, we give the actual outcome, test sparse, negative, and then our predictions, predictRf. To compute the accuracy of our random forest model, we sum up the number of cases we got right, 293 plus 21, and divide by the total number of cases in this table, 293 plus 7 plus 34 plus 21. So our random forest model has an accuracy of about 88.5. This is a little better than our CART model and still significantly better than the baseline. But due to the interpretability of our CART model, we'd probably prefer it over the random forest model. If you were to use cross-validation to pick the CP parameter for the CART model, the accuracy would increase to about the same as the random forest model. So we can see here that we can reasonably predict sentiment even with a relatively small dataset of tweets.